Okay, so this is STATS243, and I'm going to try to teach the whole of chapter 1. Now, I'm a student, I'm not a lecturer, so when you're watching this, I'm a student, but I can teach. Okay, so first we're going to do data mining. Right now, data mining and data machine learning or machine learning is different, right? Data mining is more of getting the data for your machine, you know. So, the best way to describe this is this, right? You got your machine over here, right? This machine here needs data. You see, machine learning is all about an AI. An AI will predict stuff. So it's basically an AI that predicts stuff, right? But you need data for the AI to work with. For example, data such as gender. If the AI doesn't know there's a boy and girl gender in the world, and you just assume there's one gender, the machine or the AI is not going to give you the best outcome, right? It's going to basically only favor boys, only favor girls. There's one example where in Amazon where they did a customer machine learning type of machine, but it was only favoring boys. At the end of the day, they figured out that the data that they provided the machine with was more boys than girls. So because there was more boys data than girls data, the machine thought that, hold on, more boys data is good, therefore it's only going to output boys. So the data that goes into the machine is extremely important. So in stats here, what we're doing now is data mining, right? Making sure the data we put in the machine is good. There's something called garbage in, garbage out. So if you put stupid data in, no matter how good the machine is, the model is, it's not going to produce the best result, right? Now data is everywhere, right? New mantra basically means when you get data, right? Data is like anything, whether you do into surveys, questionnaires, you need to know things from people. New mantra basically means you just get those data. You don't worry about whether the data you get from the person is good or bad. You collect the most amount of data possible, right? You don't go in a questionnaire and question a person and write down the answers and be like, no, sorry, I don't think this answer is good for my model. No, you collect the most data possible. Then after a couple of days after, you go and sit through the data, look what's good, what's bad in the data, take out the data and whatever, right? Expectations, obviously you expect the data which you collected now to help you, right? You expect it to help you in your model. What is data mining? So I told you data mining is basically the process of extracting valuable information from data. So data mining and data query is different. They'll trick you, right? They'll say you look for a number in a phone book. That's data query. It's not data mining. Data mining is getting value from data. If I say looking at a phone book and basically getting all the numbers that the name starts with S, for example, will that be data mining or data query? It'll still be data query because a human can do that, right? Data mining is more like getting value from it. For example, predicting which people in the phone book is rich. You see what I'm saying? So that's data mining, getting valuable insights from data. Now, why data mining? Well, you need data mining in order to create a machine model. Data mining is very good because you're extracting information of value from data, right? You're getting good things from data. If you're a business and if you want to know to predict the sales or you want to know how many people are buying which products, data mining is needed. You need data. So why data mining? So it helps you to extract value from information. If you have data mining in Moodle and all, it can access how long you use the site for and can see whether you are actually paying attention in your lectures. No, in the app. What is data mining? So data mining, also known as knowledge discovery from data, is basically getting value from data. That's the simplest one possible, right? So data mining obviously is needed for all these three things: statistics, machine learning, database systems. They all need good data from a specific point, right? You need data. Data is an input for almost all things in this world, right? Now, traditional techniques may be unsuitable due to data that is. Now, data mining, what is the problems with it, right? We have large scale data. So large scale data is too big, right? Oh, sorry. What I mean by traditional techniques is if a human has to do all this data besides data mining, it's going to be very like these things, so large scale. So if one person sits over there and extract the data to find value, it's going to be large scale. There's too much of data. Highly dimensional. Highly dimensional means it's too complicated. For example, you in Excel, you get like a customer, you get the name, surname, the age, the address, where they stay, where the cell phone numbers. There's too much of information stored to one customer. There's too much of descriptions stored to one customer. So it's very highly dimensional, right? It's 3D, it's 4D. Heterogeneous. Now, data comes from many forms, right? You can either get data from a piece of paper, you can get it from Excel, you can get it in PDF form, you can get it in picture form. You have to transform all these things into one type of data. So it's like data transformation. Complex data can be very complex, right? Hard to interpret, right? Distributed, there's different data that is stored in different systems in a business, right? You might get one data stored in America, might get one data stored in Antarctica. So bringing those two things together is a problem. Data mining steps, the way you easily remember it is very easy. KISS, KIS, and then KISS, and then basically the last four is very self-explanatory. The last three. So it's KISS T, right? And then the last three is easy. So KISS T, C stands for cleaning, I stands for integration, S stands for what does S stand for? Selection. T stands for transformation. Then I know you do data mining, you do pattern evaluation, and noise presentation. These three, it's like you know it, right? So what's all these things now? To do data mining as steps to get value from data, right? You got all this data, this customer information. You need to know value from it. You need to know like how many customers bought this product or whatever. You need to go through the steps. Data cleaning. Data cleaning is basically removing data that is not relevant, right? If you got a name of a person, right, and you got the age, and the next row you also got the age, that's stupid. Like, that's repetition. So remove data that you don't want, because when you put all those data into the model, the machine learning, they duplicates data. It'll destroy the machine learning, make it slow down. So you need to put good data. Data integration, same thing I'm saying, right? It comes from different files, from Excel, from PDF. You need to make it in one file. Data selection is selecting the data now what you need for the model. So it's very good to select the data that you need, right? Don't select data that you don't need. If you look at customers' information, like if they got their address, the address has nothing got to do with predicting the sales, right? Or it may sometime, but if it doesn't, for sure doesn't got to do with predicting sales, you don't need to extract that information, right? Data transformation. So this is where you put all data into one, right? So if you have sales figure, instead of putting the sales figure of every single sales representative, you can put it in one figure, right? Sales figure. You can add all them up together. Then data mining, as I said, extracting valuable information from data. When that is done, you look at a pattern that the data has. Then you noise presentation. Now this is your final. So now this is where you get your results, what you actually wanted. So now you know how much sales figure this is, whatever you wanted to know in the beginning. So this is the same steps they did before. What is data mining? Okay, so what is not data mining? Very important, huh? I told you query. Looking a phone number in the phone directory, that's a query. You're not extracting valuable information. That's not already. What is that? Certain names are more prevalent. So if you look at which names are the most common in certain provinces, that's data mining. You're not just looking at the names, you look at the most popular names. You see, that's value. Most popular names. It's adding value to the data, which is just names. Grouping together similar documents. So again, that's value. The data is all documents, but the value is grouping specific documents. So it's adding value to documents, separating it. You see, that's data mining. Data mining tasks. So in the whole data mining process, right, there's two ways in which it's done. Descriptive mining or predictive mining. These are your goals. So if you have descriptive mining, you basically want to create a model, or you basically want to get value that describes the data. If I want to know, uh, categorize or put it separately, all the documents, so PDF put it separately, pictures put it separately, whatever, these are descriptive mining tasks. Predictive mining task is predictions you make. You want your data model to be predictive. So you want to know what is the next month's sales figure will be. That's predictive, right? So machine learning, you either can create a model that's predictive or descriptive, right? It'll either the machine will either describe the data for you, its characteristics, or it can be a prediction model, predict stuff for you. So same thing I just said, right? Now data mining techniques. The techniques to data mine is basically the way in which you handle data, right? You obviously got this data, but now you have to basically put it in a way where you can put it in a machine learning thing, right? There's four ways: clustering and predictive modeling. These both are represented as prediction methods, right? So what you want to always group these as prediction methods, group these as description methods. Now just to explain each one, clustering is very easy, right? It basically clusters, it selects data from a huge data set and categorizes them. So you know how earthquake alerts, right? Earthquake alerts the people of the world when there's an earthquake. So let's say if an earthquake is represented here at red and the seismic activity is 3, for example, right? So let's say now the system, this machine is running. And right now, every single second, it's generating the seismic activity. So let's say it's 1, then it's 1.5, then it's 3. As soon as it hits 3, it's going to recognize that, hey, 3 fits into this red column. This red column says earthquake. So now it's like, hey, earthquake alert. So you see what I'm saying? So it gathers all its data and puts it into these 3 things and to categorize it. This blue might be non-earthquake. This might be a tremor. You see? So it looks at this data and categorizes it. That's your prediction modeling. That's your predictive, obviously predictive mining. This predictive modeling is very, very simple, right? Predictive modeling, you want to know what's your sale for next year. Predictive modeling. Association rules, it's a type of technique where you put together things of similar interest. If you own a business and if you want to know people who buy bread, what similar products they buy, you might figure out in the data mining process that they like to buy milk, bread and milk. So your AI or your machine or your data set you're doing will basically put these and two together. Abnormality detection stems from abnormal. So abnormal. So let's say if you have a data set that's normal and somehow you get something that's abnormal, that's an alert. For example, how do I say it? Okay, so you own a company, right? And every single day there's about 100 to 200 people that are using your website. All of a sudden, there's 1,000 people. So that's a big abnormal, right? Because you only had 200, maybe 300, maybe 200, maybe 150, but all of a sudden you have 1,000. That's an outlier. So it'll alert the system and now it'll sound an alarm. So that happens when you get hacked, right? There'll be more users in the system. So that's abnormal alert, right? Now, predictive modeling is categorical classification. So, as I said, prediction, when you want to predict the sales figure, it's going to obviously basically use all its categories, numeric, regression. Regression is the regression line of best fit. You know that line of best fit we learn in STATS243, whatever. Yeah, it can predict stuff, right? So that's what it's talking about. Clustering, I told you, it's grouping of similar objects like an earthquake and so on. Association rules, I told you, market based, you want to know what products are bought two together, right? Common outlier detection analysis, this is for abnormality detection, right? So when you want to find an outlier detection, I told you, scams and all this is the best to work with because it finds the outliers. It's like an alarm. So classification and regression, these both are prediction, and description is all these ones, right? Techniques. Now, driving a customer's company according to the agenda, no, this is data query. It's not data mining, right? Uh, Dividing customers, that's data mining. Computing total sales, that data mining. I'm sorry, that this is not all these are not data mining. Sorting a student database, no, all these are data queries. But predicting, as soon as you see the word predicting, is data mining. Predicting future stock is data mining. Monitoring the heart for a patient for abnormalities. This you'll use your abnormal detection we used earlier. So when the heart rate is something where it's not your heart rate, then it gives you an alarm, right? This will happen in hospital. So this is obviously data mining. Earthquake activities, there we go. Classification, right? Data mining, right? Yes, we did this. Um, what is machine learning? Is basically now where you feed all the data you did now in the previous slides and create a model that predicts stuff, right? Predicts stuff. What is machine learning? So obviously it learns and it acts on it, right? So it continuously learns. This AI learns, and it gets very, very quick and efficient. Now, a label and unlabeled data. So data can be labeled or unlabeled, right? If I put all these things in the machine, cat, dog, it recognizes that dog looks like this, cat looks like this. But if it's unlabeled, there's no label for it. You see what I mean? Now, the way or why they tell you that is this. When you get supervised learning, you must know that it's labeled. Label, where's label? There we go, labeled. So supervised learning is basically training a model to recognize certain things. So if you the best way to describe supervised machine learning, when you think of supervised, think of an adult supervising a kid, a child. They will literally show the child a picture of a cat and below it has the word cat. So after a while, when you keep doing this to the kid, if you show a picture of a cat and if you show a picture of a dog, the kid will recognize or point out which picture of the two is a cat. So this is how the machine actually works, right? When you give it a picture, it'll tell you whether it's a cat or not because it learned from previous experiences. You show them this is a cat, this is the label for the cat, CAT, and above is a picture. So that's how it's this, huh? Reinforcement learning algorithms. Reinforcement learning algorithms. This is trial and error, right? Basically, it's where you do not know what you're doing, but you learn as you go on. It's like students, like we just learn as we go on, right? The best way to describe this is a game, right? A game, let's say you have a game that you don't know how to play before. You'll press one button and you'll get feedback. So maybe you press a button, the car goes. You press the button side, that goes to the side. You really do not know how this whole game works. But you slowly learn and learn and learn how the game works from scratch. This button does this. Oh, I know what this button does now. So that's how this machine learning works, reinforcement, right? This could also be self-driving cars, right? They don't know what they're doing. If they go and they meet in an accident, they know, oh no, let's not drive too fast. Or if they go and they shoot a red bottle and crash, did I say red bottle? I mean red robot and crash, they'll be like, oh, now I know not to shoot a red robot. So that's reinforcement machine learning. Unsupervised machine learning is the opposite of supervised. Unsupervised, there's no labels. So let's say 50% of data you put in the machine is labeled. So you got cat and below it CAT, cat. And then 50% of the labels are not cat. They'll just show a picture of a cat but no words like CAT under it. So what the machine will does now, it's going to look for all the cat's images with the cat label and be like, oh, this is how a cat looks. And those pictures that are not labeled, the machine will label it for you. So it'll be like, oh, I know this is a cat. Let me label it cat, CAT. Let me label the other label cat. So although half of the pictures are not labeled, it'll do it for you. That's unsupervised learning. Semi-supervised is mixed. There's labeled and unlabeled data, right? Oh, sorry. What I just explained now is unsupervised. Semi-supervised. The cat thing where you did half of the pictures not labeled, half the pictures. Yeah, that's how I was actually explaining this. Unsupervised is basically there's no labels, right? There's no feedback. So unsupervised is basically where there's absolutely no labels, right? So this is the best way to describe unsupervised is a normal categorical machine learning thing, right? So you're given specific, like, let's say cars, and the machine will basically say, okay, this is BMW, this is Mercedes, this is thing. You're not going to tell it anything, right? It's going to get information from you. I just want to say an example because you have to get this. There we go, an Airbnb, right? Or Google News. So it groups stuff together. For example, if you look at a TikTok For You page and you search in the For You page hashtag cars, your screen will basically have all car videos. So this is clustering, or this is unsupervised learning, right? So you don't need to provide it with like labels or things or pictures. No, it already knows categories of things. So that's unsupervised. Huh? I already discussed this before when I was doing this by mistake. And this is the example, right? Supervised, unsupervised, reinforcement, and semi-supervised. So why machine learning? You can do tasks very, very simple. Now there's a big argument, right? Okay, that's done. Now there's a big argument, right? Is why must we make a machine learn? Why not create a machine that already has learned everything and like do the tasks? The reason is this, right? It's gonna cost you 1 million rand to create a machine learning model. It's gonna create you 50 million rand to create a model that's already learned everything. Also, it's gonna take 6 months to create a machine learning model, but it's going to create 3 years to create a fully learned model. So machine learning model is like raising a child, huh? Now obviously this won't work, this example very good, because raising a child is expensive, but let's say raising a child is very, very cheap. So if you buy the child, okay, this I might get sued. If you buy the child for 200 rand, this is just an example, by the way. If you buy the child for 200 rand, right, and adults sell for, so let's say an adult sells for 1,000 rand. It'll take 1 year for this child to become an adult, right? So this child, although it's cheaper, it's gonna learn, and become an adult one day, right? It's cheaper. So although you're not buying an adult for 1,000 rand, which already learned everything, you're buying a child for 200 rand, you're saving. So machine learning model is good because you buy it, it's cheaper and it's more efficient. And yes, it'll learn. Also, it's very good, it's very effective because when a machine learns stuff, it can learn stuff what a human cannot read or do. If you create a model that's already learned, you already told the model what it needs to know. So the model can't learn more things that you don't even know yourself that coded in the machine or should have put in the machine, right? So machine learning is very efficient and very good, right? Still expensive though, but yeah. And yeah, that's it for this chapter.